Okay, in this video, we're reviewing our Peardeck chemical reactions quiz review. You will have the quiz the next day that we work on this for it. And so we'll see that the first question says circle the reactant. So always find your yields arrow, and you'll see that your reactants are going to be on the left side. Remember, our reactants actually point to our product. So we'll see we just have one reactant in this equation. Now the next one says circle the products. So just like I said before, find your yields, and you'll see that our reactants point to our products, and we'll actually have two products in this chemical reaction. Now match the state of matter with the statement that matches with it. So we would see that L represents our liquid. AQ just means dissolved in water, and our fancy term is just aqueous for it. S would be solid, and then we would see G represents gas. So when we see these states of matter, they're going to be the thing that's behind our chemical formula that's in the parentheses and smaller. Now, using the equation up top, we're going to say, what is the formula for the second product? So we have our first reactant, we have our second reactant, we have our first product, and we have our second product. And we know that because our yield separates our reactants from our products. So I'm going to circle my second product, and when we're talking about formula, we're talking about the chemical formula for it, so we'll see that it's CO2. Now, what is the coefficient, aka the front number, of the second reactant? Because I've already labeled it, I see my second reactants right here, and I'm going to see a 2 in front for that coefficient, which means that you have two sets of O2. Now, where does the coefficient go on the formula? So just like we talked about in the last one, we're going to see that it's in the front. So normally, when you're balancing, you'll see that you have a line in front that lets you know that your coefficient's going to go there. Okay, what is the state of matter? So that means solid, liquid, gas, or aqueous for the first product. So draw our line down. We have our first reactant, second reactant, first product, and second product. So we're going to look on our first product, and we see that it is an L, representing that it is a liquid. Now, what symbol represents yields? So when we hear the word yields, our symbol is an arrow. Now, how many hydrogens are in the reactant? So find our yields. We're going to have our reactant side over here points to our products. So how many hydrogens? We're going to have 12 of them. How many oxygens are in the product? So we find our oxygen. We not only find it here, but we also find it here. And because there are coefficients, we have to multiply it in. So 6 times 1 would be 6. And then 5 times 2 would be 10, so we would actually have a total of 16 oxygens on that product side. Now, the reason we can just say 12 for the first one is because the coefficient was just 1 for it. Now, translate the following word equation. Sulfur, don't hassle the Brinkelhoff. Is it one of the diatomics? Nope, so we'll just have plain S. And would be our plus sign, and then we have diatomic oxygen, which is a part of Brinkelhoff, so O2. Our yields lets us know it's our arrow, and then it says sulfur dioxide. So sulfur, remember that di represents 2, so SO2 for it. And you'll be translating probably a molecular compound on the quiz because that was our most recent nomenclature for it. Now we're balancing the following. Find your yields, make your list, so Al, Fe, and O, and then we have Al, Fe, and O. So don't look up at the top for the second part of it because you want it in the exact same order. So on this side, we actually see there's no subscripts, so they're all 1. Fe would be 1, Al would be 2, and O would be 3. So if we start with our Al, how do we make a 1 look like a 2? We're going to have to put a coefficient as a multiplier for 2. So 2 times 1 is 2, and my ALs are good. Now I have 1 Fe and 1 Fe, so that looks good too for now. Then we have a 1 and a 3. So how do I make a 1 look like a 3? I'm going to place a 3 up top. So that not only changes my Fe, but it also changes my O. So now my O's are good, and then go back and balance that Fe for it. And we can put a 1 in the last one for it. Then don't forget to check. We have 6 and 7, 8. We have 6, 7, 8, and we are all balanced for this, aka our reactants are equal to our products. Now our next one we're balancing also, so same process. Draw your line from your yields. K equals 1, Br equals 2, and then we have K and Br. So K equals 1 and Br equals 1. So K's look good for this one, but now we'll see we have a 2 and a 1. How do we make a 1 look like a 2? We need to put a multiplier, but it not only multiplies the Br, but also the K. So whereas our BRs are balanced, we now need to make a 1 look like a 2, so we're going to multiply it by 2. We can put a 1 here if we'd like for it, and notice that we have 4 and 4, and we are all balanced for it. Okay, let's balance this one. Now this one's a little bit more complicated because we'll see that it's in 2 positions for it. So let's make our list first. So C equals 1, H equals 4, O equals 2. Then we have C, H, and O on this side. So we have C is 1, we have H is 2, and then we have 2 plus 1 for our O's, so a total of 3 oxygens for it. So I would always save my oxygens to the end. So how do we make a 4 and a 2 look similar? So think about what can you multiply 2 by to get to 4? It's 2. So we're going to change that there, and it also changes this 1 that we had before to a 2, so we now have 4 oxygens for it. Our C's are still balanced, our H's are balanced, and then how do I make a 2 look like a 4? I multiplied by 2. So now we are all balanced here. So notice when we have to add up like terms, you saw that I kept it separate to show that I'm only changing the second O and not the first O for it, meaning I would have 9 atoms here and I would have 9 atoms here, and we are all balanced for this one. Okay, our final question for our review. Why do we balance chemical formulas? The hint is, what law are we trying to prove? So we are trying to prove the law of conservation of mass. That matter cannot be created nor destroyed, and we're looking to equal our reactants to our products. So thanks for watching, and good luck on your quiz.